Today we're going to learn about the 3 tenets of object-oriented programming. Exciting stuff, I know. Let's go to the code. So what are the 3 tenets of object-oriented programming? Well, let's find out. So we're going to start with a classic example of a shape, which is an abstraction of various geometric entities. So the first tenet that we're going to talk about is inheritance. So we have our abstract shape here, just an amorphous geometric entity. And so what we're going to do is we're going to create 2 other classes that inherit from this thing. We're going to create a rectangle that's going to inherit from shape. And then we're going to create a circle that's going to inherit from shape. Now our shape is empty right now. It doesn't have anything. So our rectangle and our circle aren't inheriting anything from our shape. So the concept of this is that when you would do inheritance, the derived object or the derived class, the more specific implementation of that abstraction, takes on the properties and the behaviors of its parent class. Just like regular mommy daddy sex, you take on the properties of your mommy daddy. You know, they had sex to have you. That's how it works, in case you didn't know. And that's inheritance. You inherited all the good stuff and all the bad stuff too. It's in you. It's circulating in you right now. So think about that when you're going to bed tonight. So let's say our shape also contains a method that we're going to call, actually, we're going to make this guy virtual because he doesn't really have a definition for a shape. We're going to call it calc area. And we're going to equal that to 0 since this is C++, and that's how you define a pure virtual function. Which, when you do this in C++, if you set any of the methods, this virtual float, if you do something like this, where you set a method equal to 0, you're essentially defining the class to be abstract as well, which means that you can't instantiate an object of type shape because its definition is not fully fleshed out, because you've said, don't create things of this. You need to create the more derived versions of this class. So we have this calc area here. It's a pure virtual. It doesn't have a definition for shape. We're also going to create a protected vector. Actually, let's do a pair. Let's make this a two-dimensional object. And we're going to put them in 2-dimensional space. A pair int. Actually, I think it's tuple in C++. It's been a while since I've written C++. So let's do a tuple, just 2 entities. And we're going to call this position. And the idea behind this is that, let's say we're building a rudimentary gaming engine for 2D two-dimensional games. And we want to come with 2 things right out of the box. We want to come with a rectangle and a circle right out of the box. And so the position here is the position of that object on a 2-dimensional grid. So I want you to think about that. So now our rectangle, now with that we have a definition of calc area, which is empty, and a position that we can set. The rectangle and circle inherit that property, position, and the behavior, calc area. So now let's move on to the second tenet of object-oriented programming, and that is polymorphism. So in our code here, so now that we've defined calc area to be a pure virtual method, anything that derives from shape is being forced to implement that method. So our rectangle and our circle have to implement that method. So we're going to do float calc area, boom, boom, and I think this is the right syntax, but I'm not sure in C++. So we got to implement this in our rectangle class, and we have to implement it in our circle class. And I'll show you what this looks like in an example in a minute. what makes it polymorphic override. So now that we have an implementation, or we have the intent that we're going to implement it in a CPP file, this is the header file. If we run down here to an example, let's say we have our int main, and we're going to create a shape. Pointer s is going to be equal to new, let's say, rectangle, like that. And then what happens is since shape is the one that defined the interface, we can call it an interface for calc area, the most derived classes that implement that method, now when you do something like this, when you do like shape s rectangle, you can say s pointer calc area like that, and it will just know that polymorphic behavior, right, is that it'll know to go to the rectangle to use that calc area. So that's polymorphism. It is defining an interface or some kind of virtual thing at a more abstract level, and then overriding that or fleshing it out in more detail in the most derived classes, so that you can do stuff like this, to where you don't need to pass around a rectangle and a circle. You don't have to do function overloading to take a circle and a rectangle to calculate an area. You could just pass in a shape, and who cares what the underlying implementation is? It'll just know to call it. So that's polymorphism. Now, the third tenet of object-oriented programming is called encapsulation. And in my experience, when I ask this in interviews, or I talk about it with my people, with other engineers, software engineers, this is the one that they struggle with the most. Like, most people can conceptually describe it. They kind of know what it is, but in practice, it tends to be a hard thing to actually implement. And let me show you what this looks like. So we have our position here, and it's protected at the moment. So only the derived classes have access to that position variable, that position member. So what if we wanted to give the public access to it, the callers, the users of this shape thing? They can't access it right now outside of the scope of these classes. So encapsulation says, in a nutshell, at least the way I think about it, is the caller, the user, whatever of this thing doesn't need to know how it works in order to use it. And that can take on the form of, in C++, in something like this, we have getters and setters. So it's data hiding. It's hiding your state. It's hiding the dirty details of your behavior, so that the user of this doesn't need to know the internals and how it works, like what state it's in or anything like that, in order to do useful things with it. So how that plays out in this example here is, what we can do is we can have a public method that returns a tuple int that is get position. And that's going to return a copy of whatever the current position of this shape is. And also, if you wanted to allow your external users to set the value of the position, to change it in some way. So you could also do a set position and then pass in a tuple. What you could pass in a tuple if you want, but you could also do like an int x, int y, so that you obfuscate the underlying details of this thing even more by saying, all I need is 2 points. I'll handle the rest. And so that's encapsulation. It's effectively saying, you don't need to control the state of me. Please don't control my state. The class itself will handle the state and the dirty details of the behavior, so that the caller can just use it however they want to use it. So that's it. Those are the 3 tenets of object-oriented programming in a nutshell. You have inheritance, you have polymorphism, and you have encapsulation. And I just gave you some examples to put under your pillow at night when you go to bed. I created some homework for you so that to drive this into your brain skull even harder. And we're effectively going to build what I mentioned before is a rudimentary two-dimensional game engine. And we're going to start by applying the lesson that you learned here, the 3 tenets of object-oriented programming, to your first homework assignment. So it's in the description. Just click the link, go grab it. It's going to cost you your email. I'm not going to lie. I'm collecting email. Yeah, that's right. I'm one of those tube ubers. I'm going to get your email and I'm going to just spam the shit out of you. No, I won't do that. I'm not going to spam you, I promise. But I do have homework and I want you to go do it because it's going to be fun and it's going to be a good learning experience for you. Just to brush up on your skills or to learn something that maybe you didn't learn in college that you can take out into the real world and, make money with. This is your livelihood, right? Let's grow those skills. So go grab the homework, give me your email address, and I'm going to just keep bringing shit like this to you right in your face every single week. I've been Aaron. This is Analog Aaron. I'll see you next time.